Good morning, everyone. We are in the flight simulator with Arnaud, our proud professional pilot with his 4,000 hours of flight, and Xavier with his good 40 hours of glider flight in 1999. Today we will create a brief video on starting up a Boeing 737, specifically the NG version, using our simulator. We're not a professional startup, we're just showing you how it works. Already on the runway, which is unusual. Normally we start up at the gate, not on the runway. What are the first buttons? So to start a plane. So as you said, it's usually here we have a support. It's a Boeing 737. We're not going to apply exactly the startup procedure of a Boeing 737. So to all the buddies who are on the machine, sorry, we're going to make a lot of breaches to the real procedure, but that's the principle. So the principle, we arrive in the plane, everything is off. One reset, everything is off, everything is on off. Normally there it's not lit, but well, the simulator does not simulate it. The first thing to do is, we're only going to talk about the technical part of the plane, okay? So we're going to start the battery. To start the battery, we're simply going to fold down a cover. Here, battery, it's actually a button that is protected by a cover to prevent it from being turned off or on, turned off unintentionally. To turn it on, remove the cover and press the power button. Folding down the cover turns the button on, preventing annoyance if the battery is cut during flight. We're going to start the battery first. The battery, we don't work on it. The battery is simply there to start the other systems. By starting the battery, it will ring, there will be an alarm saying be careful, you are on battery. Do not stay on battery for more than a quarter of an hour because after that it will be drained. And to change a battery on a plane like this, and on all planes in general, it's quite complicated. It can take time. We will start the battery, we will have an alarm, and then we will directly connect the auxiliary power unit, which is the auxiliary power unit. So the auxiliary power unit, very often, when passengers board a plane, the engines are cut off, but there is current on board, electricity on board and air, and that it's generated by a small reactor that is at the back. So this small reactor is not there in the tail of the plane. This reactor is not there to give power for takeoff, but simply there to provide electricity and air. And the air, we will need it already to ventilate in the plane and to start the engines. There is also another possibility. One was talking about adding, when we have the airport itself, we can plug into the airport. To go to the electricity, it's the ground power unit, So the problem with the ground power unit, it's not free. Yes, but oil is also yes. Yes, that's true. So we're going to plug in the battery. We're going to have an alarm to remind us that we're on battery. And right after, we're going to start the PU. Before starting the PU, we're still going to put a fuel pump afterwards. So it's a pump, that one, which will take kerosene to bring it to the auxiliary power unit. It's a bit like the fuel pump of the car. Let's connect the auxiliary power unit. I'll fold back the cover. It rings, which is normal. We connect our fuel pump. There we go. And we're going to start the auxiliary power unit. So there are 3 positions, off, on, and start. We press once on start. There's a whole procedure that starts. We generally take a stopwatch to see how long it takes to start. So it's the manufacturer. Yes, that's the temperature there. The temperature rises. We have lights that come on. And we have a light here that lights up telling us we have electricity available from the auxiliary power unit. So the auxiliary power unit is running. So one, plug it in, it will cut off the alarm. This auxiliary power unit is running. By running, it will run generators. The generators, by running, will generate electric current, which will then be controlled by a voltage controller. And we have 2 generators. So we have plugged in one, we will plug in the second one. So these are generators that we can use in flight in case of emergency. If we have the main generator of the left engine or the right engine that breaks down, we always need to have 2 generators connected to the plane. So if, let's say, in flight we have this generator that is connected to the right engine that breaks down, we restart the auxiliary power unit and we will connect this emergency generator of the sudden. We can also use it as a backup in flight. So we saw earlier when you press that button, instantly we have the screens in front of us. There we have the essentials that are lit up. So for now nothing is initialized. So we don't have much on our screens. So we've turned on the auxiliary power unit. All that's left is to start the engines. That's all. There you go, it's simpler. To start the engines. So I'm not talking about the instrumentation part. Okay, to start the engines, again, we're going to have to put the pumps on ON. There are 3 tanks on this plane, 1 tank on the wing. We can see it here. This is represented the tank on the left wing, the kerosene tank on the right wing, and the central tank. There is an order to consume the tanks. We will talk about it later. Maybe on each tank it is necessary. Pumps that bring the kerosene to the engine. And there are 2 pumps per tank. We've already put a fuel pump on the left tank. We're going to put the second one. And we're going to put the 2 fuel pumps on the right tank and the 2 fuel pumps on the central tank. This plane, when there is kerosene in the central tank, both engines will take kerosene from the central. It's automatic. And when the central tank is empty, automatically each engine will take the left engine from the left tank and the right engine from the right tank. There is also a way, if we need to transfer from the right tank to the left or from the left to the right, there is a way to do cross-field, as we call it, to transfer kerosene. In fact, we have a small cross-field button here, which is used to make kerosene transfers. To start the engines, we are going to take air from the auxiliary power unit. So currently, the auxiliary power unit is supplying us with electricity and air in the plane. We will use air from the auxiliary power unit. This isn't the correct example, only the pocket engine remains, and we'll light it. In addition, it's not the right plane model. We are going to take air from the auxiliary power unit, and we are going to inject air into this engine. We are going to blow into it by wind effect. The engine is going to start turning dry because there will be no kerosene in it. So it will turn, and once it reaches a certain percentage of number of turns, we will be able to inject kerosene into the engine, into the combustion chamber plus sparks. Once the kerosene arrives in the combustion chamber with the sparks, there will be combustion. As the engine will already be driven, there will already be an air cycle. The hot air will expand, it will continue the same direction of air circulation originally, and the engine will start, and then we will cut off the air supply from the auxiliary power unit, and we will cut off the spark in the engine. It's a bit like a lighter. Once the lighter is lit, we no longer need the spark from the lighter for the flame to maintain itself, so we have the pumps on. We are going to take air from the auxiliary power unit, bleed. It's all about air management. We are going to take air from the auxiliary power unit. We open a valve at the auxiliary power unit level. The air valve opens, so now we can take air from the auxiliary power unit, and now we are going to ask the plane engine start. It's to start the engines. This is for starting engines. We are going to put it on GRD to start the engine on the ground. So now we press here. We see here marked start valve open. It means that the right engine's air valve is opening, and we are going to inject air into the engine. We see that the engine is starting to turn. We hear the noise and arrive. Depending on the manufacturers, here it's at 20%. We are going to inject the kerosene. The kerosene, we already have pressure in the kerosene ducts, but we haven't opened the valve at the level of the right reactor. So here the kerosene is ready to go into the right engine, but we haven't opened the kerosene valve yet. And now, right engine, so the second one, we're going to open the kerosene valve, hop into the right engine. And we see that here the engine temperature is starting to increase. So we have to be careful. We must not exceed a certain limit. So each time we keep our hand on the kerosene valve, because if the temperature increases too much, we cut off the kerosene supply and it will instantly stop the engine temperature rise to not destroy it. Then we do a vacuum ventilation to cool the engine, and we restart the startup. We always use a stopwatch when starting the engine to ensure it lights up within the manufacturer's specified time. For example, if the manufacturer states it should light up in 30 seconds, but it's still not lit after a minute, there is a problem. The engine is now on. We have the temperature that has dropped back to 460 degrees Celsius, because at the beginning we had a quantity of kerosene, and the engine was running weakly, so it was not ventilated enough. So that's why the temperature rises, and then the engine starts to take its cruising speed and ventilates well, so it makes the temperature drop. The startup went well. And we have the little button here that resets itself to off on its own. Putting it on ground allows the air valve to open and spark to be put into the combustion chamber. When we inject the kerosene with the spark, there is combustion, like a lighter. If we light the lighter's gas, nothing happens. If we put the sparks, there is a flame. Then we can stop the spark, but the flame continues. So here we have stopped the spark. The process is the same for the left engine, which also uses air. We have pressure at the kerosene level, and while there we are going to open the air valve at the level of the left engine of 1. We look here, we take a stopwatch, we look here at the percentage by wind effect, so the engine turns geo effect. Finally, not yes, wind, engine turns, and towards a certain percentage we will inject the kerosene. So there are sparks that are in the combustion chamber. There we open the kerosene. With the sparks there is combustion. The temperature rises. We look, we make sure that it does not exceed a certain value. The engine picks up speed, so the temperature decreases. We heard the click of the start button that stopped. We looked at the parameters are well stabilized, and the procedure for starting the 2 engines is finished. And so we see the engine power, which is displayed here. We are at 21%. It's 21% of the fan, of the big fan, of what we see in front. When we stand in front of the engine, there are the fins that we see are called the fan. And the power percentage of this fan is here at idle. It's about 21%. Once we have the engines running, we can take the electricity from the engines and no longer from the auxiliary power unit. So it's the same. It's the management of the generators here. So generators currently, we are connected to the 2 generators of the auxiliary power unit. But in flight, we have to cut the auxiliary power unit so we can turn it on in flight if we have a problem. But here we see the normal, we cut it off. So now we're going to connect generator 2 and generator 1. 1 refers to the left engine and 2 to the right. We use 1 and 2 instead of left and right to avoid confusion when facing someone, as there's no question of whose left or right it is. And the generator of 1, therefore the auxiliary power unit, has disconnected at the generator level. The blue text indicates that the person is still present and available. If you need me, in blue it says, if you need me, I'm available, and then we're going to look for air. Now we have air from the auxiliary power unit, but we need air from the engines to pressurize the plane, to defrost the plane. So we're going to take the air from engine 1, the air from engine 2, we're going to cut off the air from the auxiliary power unit, and we're also going to set it's called the PEX. It's to pressurize the plane and provide air in the cabin. We're going to cut off the auxiliary power unit, so we're going to set it to off, and we don't lose anything. We don't lose air. We don't lose electricity then. Normally we do it with checklists, the startups. We check well there, as we are not trying to stick to a real startup of this type of plane. We do it a little bit, it's a generic startup. We will connect some flight assistance systems, which is called the U-dumper. For those in the know, we might talk about it later like that. Then we're going to put an electrical system for the cabin. We're going to strap the passengers, the little gift that everyone likes to hear. Put the airplane's de-icing system, so we de-ice the windshields. It's always de-iced. And the pitot tubes for measuring speed. Then we will also put the electrical systems of the electric hydraulic pump. So everything that is control of the plane. It's like on a car, the clutch, the steering is hydraulic. The plane is the same. We can't fly the plane directly in direct contact with the ailerons, so we have a hydraulic system that helps us. The hydraulic system works with this system. So there are 2 circuits on this type of plane. There are 2 hydraulic circuits that are on. One works without the other, and a hydraulic system can power the whole plane. So if we lose a hydraulic system, it's not serious. And each hydraulic system has 2 different types of pumps. So here it's a mechanical pump that is taken directly from the accessory box of the engines. So the running engine makes systems that turn a hydraulic pump, so it gives us power at the control level, and we have an electric hydraulic pump that we plug in for system A and for system B. Then we managed our air, the air in the plane. One forgot to follow the checklist before starting up, because one did it from memory. We should never start up or do anything from memory. We do emergency things from memory, but we do things, the startup, all that. We do it with checklist 2. So one forgot to input before the startup the anti-collision system. So it's the red lights that flash, and when the red lights on the parking lot light up on a plane, it means that the plane is going to start its engines. Then we can put on the taxi lights, so there the plane is on its way and ready to go if we don't look at the whole navigation system.
Great. And so next, we're not going to do it because it's a little longer, but if we were, for example, where we are in Nice, if we wanted to go to Italy somewhere, what is the equipment that we would configure?
So to navigate, we're going to look for the routes we're going to take depending on the destination. If we're departing to the north, south, east or west of the airport, there are routes to follow. The plan includes arrival routes at the destination airport. In between, there are low and high altitude road maps showing the necessary routes to follow. Once we've looked at the routes to follow, which are published by the Aeronautical Organization, we're going to enter them into the onboard computer. And for the onboard computer, we get to a page where it says here origin destination. We have to state the origin field. So all fields consist of 4 letters. LF, MN, so everything that is LF are the French fields. MN, it's Nice, PO, Orly, PG, De Gaulle, PB, Le Bourget, there you go. And then once we've determined, so we write here LFMN, so this is Nice. We write it here, we copy it there, well it was already copied, and then we're going to select the route, the runway we're going to take off from. So there are different types of runways. The 04 left, right, the 22 left, right. So 04 is because it's oriented at 0. 41 degrees is the orientation.
Magnetic, so everything between 0.36 and 0.44 is going to be the 04 runway. So everything that is runway 22 is from 215 up to
224.
That's why sometimes the tracks change names, because
the magnetic pole moves a little bit. It's the magnetic orientation, but well, they haven't changed geographically. So we choose runway 4 left, because here we are to the left of the runway. Hop, so it appears here. The fact of selecting the takeoff and arrival runway, so here, 1 took the same one on arrival, 04 left. It will make it appear on the navigation display, the ND, so this is for navigation, and we see here, 1, I'm going to zoom in for you.
So just to explain now, there are different colors that correspond to the reliefs that are around us. Here we are at the Nice airport. One look outside, so obviously we see there are mountains, and on the right it's rather the sea, so that's why we have the black underneath us, the yellow and the red, which are higher than us. So the red means that if we do nothing and move forward, yes, that's bad. One tease to avoid what they call controlled flight 1 and 2 terrain, controlled flight 1 and 2 terrain. It was pilots who were a little bit lost in the situation, so we're talking about the 70s, who couldn't figure out if they were higher or lower, because notably there are very well-known examples where the pilot had entered a valley because the air control had been broken in Central America because of the rebels. One think it was in Colombia. So there are many examples like that in which the pilots were a little bit lost. They had confused the entrance into a valley, and so we had installed this system that allowed to reduce collisions, the controlled flight 1 into terrain, which was the first cause of human accident. Cause of human accident, yes. Once we had swept away all the technical elements that almost no longer existed at that time, then listen, we are capable of taking off, then yes, you want to go...
Where takes off? Okay, we're going to do the Aero Club then for the takeoff. There is still on a plane, there is the base to respect is already. Do we have enough kerosene? Yes. For the mission we have to do. Yes. Do we have the kerosene tank open?
Both.
Are the pumps on? Yes, we have the pumps on. And that's really the basics of the basics. Whether it's a small Aero Club plane or an A380 or Concorde or 747, that's the basics you need to have. One have kerosene, one do. And besides, it feeds my engines well. Well, that's something. Do we have the flaps to take off? The flaps, it's good, no need to explain.
Yes, we saw it. When flying at low speeds, flaps need to be extended to increase the wing surface area. Well, we'll explain it in detail in a future video. So,
The shutters, we're going to set them to 5 if you want.
On 5, keep your hand here until then.
There, or me, but there still needs to be some control. So the action, we say we action verification. Action, you have pulled out the shutters.
Now, we control. And here, one will zoom in on the next video, has indeed the actual position of the shutters that are displayed, and so the shutters are out at 5. It's like a child, isn't it?
Did you clean your room? We'll still check even if you say yes. So, action verification. We do have the shutters at 5. The landing gear lever, train as it's a retractable gear plane, it's indeed on down, because if we put it on out, if we had put it on retracted, the landing gear will not retract to the ground, except that the acceleration, the plane will take suspension, lift, so the weight on the landing gear will become lighter and lighter, and at some point the gear will retract, and then we will end up on the belly. So we need to, it's a shame, because in The Simpsons, when you press the button, the trains will retract. It doesn't work like that. The Simpsons are not credible. Oh darn, that's the truth. One didn't want to hear. And then the air brakes are well engaged. The air brakes are the parts that are on the wing to brake the plane. And the automatic braking on RTO, in case we have
need to brake like that, it would do the automatic braking to the maximum.
We already discussed RTO in the video, including failure before or after V1. Exactly, we would put the link back in the comments of this video. As usual, it makes me squint putting the parking brakes on the runway, but as you said, it doesn't go on the runway. One come in, one take off the brakes, so there it's the handbrake of the plane on the real plane. It's not done by hand, it's by foot. We brake, we override the brakes and snap it stops, because
remember, we have foot pedals for braking and turning right and left when we're on the ground. The brakes are at the end of our feet, not controlled by the steering wheel. There is a wheel here which is on my left one, do a little zoom on it, which allows us to orient ourselves when we are on the ground, but we can also orient ourselves by turning right and left one. Just show you the nice lever which is on my left, and so that allows to orient the nose wheel of the plane to be able to direct ourselves when we are on the ground. For example, to return to the
parking lot then.
There.
One should clarify for the purists that this is not a normal procedure. We arrived like this. We didn't follow the real checklist, so there were surely some oversights on my part. But it doesn't exist in reality. Go on, you figure it out.
How much am one showing? 60.
So we're going to start at 40% of N1. We're going to take 40% of the left engine and the right engine of 1, and 40% of N11 if you want. One can film you.
I've advanced 40%. I've displayed 40. You can see the little train at the top.
It's the request at 40. We indeed have 40%. The fact of making a plateau at 40%, it allows to see if there are no vibrations or temperature problems, oil pressure. It allows to stabilize the engines at 40%. So when we put a lot of power, the engines will already be strong enough to reach 90% at the same time. Because if we go from 20% to 90%, one will go faster than the other. However, from 40% to 90%, they will start at the same time, and it avoids pumping. But on modern planes like this, with the full authority digital engine control, managing the power, the electronic rise of the engines, there is no more pumping. Listen, you'll put 40%. Normally we do a pre-departure safety briefing and talk to the control tower. We've been authorized and done everything needed. We didn't say it, but we did it. Go ahead, put it at 90% power. So now I'm displaying like before. 90%, the other hand on the stick, your hand here just before 5-1. Feet on the rudders to be able to turn. So the simulator is very difficult to pilot during taxiing. It's even more difficult than the real plane. I'm checking the power. You keep looking outside. I'm checking inside. I'm checking that the takeoff powers are well displayed. The speed is active. We've passed 80 knots. Great. It was compared to 80. Of course, we had announced the speeds. 5-1, 5R, and rotation. So now we're getting to 5-1 and tomorrow on the stick and rotation.
I'm taking an angle of
takeoff of
15 degrees once you have pressed.
We've taken off from the runway. You can look for your 15 degrees of attitude now.
The
is positive. That is to say that we are climbing. You announced to me to retract the landing gear. Therefore, you're the one in charge. You're the conductor.
Well, one. I'm going to stay on track.
At 15
Degrees of ascent.
Even now, we can turn right. So you can ask me to head 180, go.
80 heading 180, so one display.
Wait a little bit ahead.
One have a little indicator that will display, which will give me the angle. Now one, I'm a little beyond 15 degrees.
So now one have displayed.
The navigation screen displays a big pink line indicating the desired heading of 180 degrees. The goal is to align the aircraft with this pink line to reach the intended direction of 180 degrees. I'm going to make a right turn.
And
you see my angle. Hold on, I'll leave you the controls here. We have our turn angle, our turn radius that's displayed, and we're going to orient ourselves on the pink line. You see the whole map is turning. Indeed, when we look out the window, we're in a turn crossing some small clouds. Thank you. Our altitude is rising. We're going to ask 6,000 feet like that as an indication. Our speed in the direction, 109. Right here, we have the wind direction, 105, and its strength, 5 knots, which gives us an airspeed and a ground speed. Ground speed through airspeed.
So in real life, we have acceleration stages. So let's say we've passed the acceleration stage. We say bug up. We're seeking a speed of 220 knots. 20. Speed displayed 220 knots. Displayed, you verified, displayed. Okay, so now we're going to speed up the plane. We're passing 170 knots, so we can now set the flaps to 1.
The flaps are set to 1.
So they are coming in here.
Coming back, so we see the actual display of the exit of the
shutters. They have returned. We're soon arriving at 6,000 feet. We heard the altitude alarm of, and we passed 190 knots, flaps on. You just came from...
Retract the flaps, and so they are here now at 0.
We will intercept by accelerating to 250 knots. That suits me very well. 250 displayed and verified. Is that good? And there we intercept the 6,000 feet. So there, we made a departure without the flight director, without the little help, the cross, which tells us what to do. We will do that
next time. As you can see, the pink line 1 showed earlier, representing our desired trajectory, aligns with our current position. It's magnificent. We're off for a flight. And now we're going to enjoy our little trip together. It's beautiful. The Arnaud Aero Club.
Thank you, thank you.
To you, it was
a nice startup checklist after takeoff anyway. We did the takeoff, it has to be finished. So the check after takeoff, we have the checklists on the stick, the normal checklists there. So everything that is air pressure is good. It pressurizes the landing gear at Boeing. It has to be put on off. That means that the pumps, we turn it.
Put it in the middle.
We
let it go, which prevents the pump from constantly running to look upwards.
Because now the landing gear is retracted and locked, so it will hold high position by the mechanical locks and no longer by the hydraulic pumps. And the flaps are well retracted, lights off, and the braking is off. The after takeoff checklist is completed for me. The takeoff is over. I'm going to do one last thing because our passengers like it. One, authorize them to remove their...
Thank you for following us. Feel free to ask all your questions. It's always a pleasure. Blue thumbs up and ask your questions. It gives us ideas for future videos. We'll see you soon for another simulator session with Arnaud. I'll see you soon. Do a barrel roll. Like this, one at a...
One took it a bit slow in terms of speed, a bit slow and a bit low, a bit slow and a bit low anyway. In real life, one wouldn't have been conscious, you wouldn't have done it in any case. And while passing on speed, please. One press.